Tēnā koutou, tēnā koutou, tēnā koutou katoa. Ngā mihi nui, kia koutou katoa. Welcome everyone to our Engineering Futures evening event, How Engineering Rewrites the Rules of Tomorrow. My name is Colin Whitaker and I'm a Senior Lecturer in Civil and Environmental Engineering.
And I'm Kelly Blinko, a Senior Lecturer in Software Engineering.
Tonight we're joined by Jane, who's a Student Academic Advisor, and three of our graduates, Orti, Israel and Ang, and they'll help us to answer that question, how does engineering rewrite the rules of tomorrow? A quick outline. Tonight we'll talk about what engineering is and how engineers do what they do. Our Student Academic Advisor will give you a bit of detail about the entry requirements for our degree. We'll be talking about what you'll do when you are studying here, and then we'll hear from our graduates about their experiences within and beyond their degree.
But first, a few housekeeping items. There's a question and answer button at the bottom of your screen. You can click here to ask us questions. We have a group of helpful student academic advisors working behind the scene to answer your questions, but you can also ask the presenters questions, which we'll get to at the end. If you don't have questions yourself that you'd like to ask, you can also upvote others' questions, and we'll get to them in priority order at the end based on the popularity of the questions. One other thing is that this session is going to be recorded, so you can always go back later and watch parts that you might have missed, or share the recording with others who missed the session. We'll email you a link to the recording at the end of the session. Now a quick video.
So before we talk about what we'll be studying within your degree, it's good to talk first about what is engineering? What do engineers do?
And first and foremost, engineers are problem solvers. They solve real-world complex problems.
Not only do they solve problems, but engineers make a difference in people's lives. Engineering is a great career, it's very secure, there's good salaries involved, but a lot of engineers really go home at the end of the day knowing that they have made a positive difference to people's lives.
In addition to making a difference in people's lives, engineering is about making the world more accessible. Engineers work on transportation, the Internet of Things, bringing the connectedness of the modern world.
So to summarize, engineers are problem solvers, they make a difference in people's lives, and they're innovators who make the world more accessible. And in each case, they do this by analyzing the problem, designing possible solutions, and then implementing the best solution, not only on technical grounds, but also considering the needs of a wide variety of diverse stakeholders. So considering what you'll be studying, our degree is a 4-year honours degree, and in your first year, that will be taught in 2 different semesters. We teach 4 courses per semester, and in the first semester, you're going to have the 3 courses that you can see on the left of your screen, and 1 of the 2 courses that you can see on the right. So Mathematical Modelling 1, as the name suggests, it's a mathematics paper, but it's really about taking mathematics, using it to construct models that you can use to solve real-world problems. EngGen 140, Energy and Society, is a course that concerns the subjects of chemistry and biology, but it really takes those and applies them in the context of energy and society. And in that course, we start to teach you also what it means to be a professional engineer. EngGen 121, Engineering Mechanics, that builds on the mechanics modules that you've taken in your physics courses to date. And then you get to choose one of General Education or EngGen 115, Principles of Engineering Design. The General Education course is a broadening experience where you get to take a subject that's unrelated to the technical subjects that you'll be studying within your degree. The Principles of Engineering Design, one of the things that distinguishes engineers from a lot of other subjects is this ability to design. Engineers design products and systems that have never existed before, and in this course we'll really run you through the design process and give you an opportunity to further develop your professional skills by working in groups and teams. Now, some of these products that may not have existed before include the bubble ship that you've seen here in the slide. Technical drawing and attention to detail is one of the skills that you'll definitely pick up on this course. Things like tolerances. And from this exploded view, you can also see that engineers really need to be able to take a complex system and break it into its component parts. Overall designing something that works and meets the needs of those diverse stakeholders. Moving forward to the second semester, you've again got the choice of General Education and the Principles of Engineering Design, and then you'll take the 3 courses on the right of your screen. Those include ChemMat 121, Materials Science. This is a materials course. It doesn't rely on any prior knowledge of the subject, but it really introduces you to the materials that engineers will use in a range of disciplines. ElectEng 101 is Electrical and Digital Systems, and that builds on the electrical physics modules that you'll have been studying at high school. EngGen 131, Engineering, Computation and Software Development, is really recognizing the fact that to be successful in today's environment, engineers of all disciplines need to be very skilled at computation and the ability to write code and software.
After the first year, you'll go more in depth into your chosen specialization. At the end of the first year, you will rank your choices for our 10 specializations. And we do our best to get you into your chosen specialization. The best way to get into your chosen specialization is to do well academically in your first year. The specializations are assigned based on grade point average obtained in the first year of study. The numbers here are showing the spaces per specialization for 2020. These numbers do fluctuate sometimes, and they're driven by industry demand to ensure that industry has a need for the engineers that are coming out of our program. And now I'll hand it over to Jane Hay, one of our student academic advisors, to talk about entry requirements.
Thank you very much, Kelly. Kia ora koutou. My name is Jane Hay and I'm a student academic advisor in the Engineering Student Centre, and I'm going to start talking tonight about entry requirements into the Bachelor of Engineering Honours degree. So a fairly new requirement was introduced in 2016 called the Academic English Language Requirement, or AELR. So the aim of the AELR is to ensure that you have sufficient level of competence in academic English to support your study at university. So the AELR may be met through your entry qualification or through satisfactory completion of an approved course in your first 12 months of study. Please be reassured that if you don't meet the AELR through your entry qualification, it doesn't affect whether you are offered a place on a program. You'll just need to pass an approved course, and this course will also fulfill your general education requirement, so you won't have to take any additional courses. The AELR courses are specifically designed to give you the necessary skills to become familiar with the language of university so you can communicate effectively in all your courses. Next, we'll go on to the entry requirements for NCEA. So these requirements are what we call guaranteed entry requirements. If you get these requirements, then we have to give you a place no matter how many other students meet these requirements. However, if you don't end up meeting the guaranteed entry requirements, we suggest that you still submit an application, because if there are still spaces available, your application will be considered. So for NCEA, you'll need to attain university entrance and a minimum 16 external credits at level 3 in physics and 17 external credits in calculus. You'll also need to attain a rank score of 260 for guaranteed entry into the Bachelor of Engineering Honours degree, or 275 for guaranteed entry into a conjoint. Next, for CIE, you'll need to attain mathematics and physics to full A level. However, we will still consider AS Maths and Physics, depending on the grade achieved. So for guaranteed entry into the Bachelor of Engineering Honours, you'll need to attain a score of 310. For entry into a conjoint, you'll need to attain a score of 330. If you're doing the IB, you'll need to attain the full IB diploma and mathematics and physics to higher level. Standard level maths and physics may be accepted based on the level of grade achieved. However, from 2021, SL Physics and SL Maths analysis and approaches may be accepted based on the level of grade achieved. However, SL Maths applications and interpretation will not be accepted. So the guaranteed entry score is 33 for a Bachelor of Engineering Honours, and the guaranteed entry requirement for conjoint is 36. However, if you don't get into engineering via your Year 13 results, we'll give you another opportunity to apply into engineering, and therefore we have created the alternative pathway via the Faculty of Science. So there are a minimum of 30 places available for entry into semester 2 after 1 full-time semester of study in the Bachelor of Science. So during the semester, you'll take 4 courses, including a maths and a physics course. And if you complete the courses to a required standard, you'll be considered for entry into the Bachelor of Engineering Honours in semester 2. So admission into the BE Hons after 1 semester in science is unfortunately not guaranteed. It's competitive entry and there are 30 places. Candidates will be ranked according to grade point average, so it's important that you do well right from the start. Now we're going to talk a little bit about scholarships. So there are a number of scholarships for undergraduate students in their first year. The main scholarships are what we call the University of Auckland undergraduate scholarships. So there are 4 types of scholarships for this University of Auckland undergraduate scholarships. There's the University of Auckland Top Achiever Scholarship, Māori Academic Excellence Scholarships, Pacific Academic Excellence Scholarships, and Academic Potential Scholarships. There are also a number of scholarships just for engineering students. So the main engineering scholarships for school leaver and first year engineering students are the Kickstart scholarships. So there are 4 different kinds of scholarships, the Kickstart scholarships. There's the Merit, City of Sales, Affirmative Action, and the Edward Connolly scholarships. So the closing date for these scholarships is the 15th of January 2021. Now there are 22 scholarships available and they're worth $2,000 to assist you with setup costs for your first year in engineering. Plus, there are more than 40 engineering undergraduate scholarships from individuals, societies, businesses, and industry, ranging from $1,000 to $7,500. Now, I mentioned conjoint degrees earlier. Conjoint degrees are actually double degrees. So many students take up a conjoint degree with a Bachelor of Engineering Honours, and if they have another area of study or another industry that they're interested in, they might take up a degree such as Bachelor of Commerce or Bachelor of Science. However, there are many different conjoint degree combinations that are available. And while the majority of conjoint students do combine a commerce degree or science degree with the engineering degree, we have conjoint students studying engineering with a broad range of other subjects, such as a foreign language, global studies, law, music, and design. It's important to note that the workload for conjoint study is significantly higher in comparison to the single Bachelor of Engineering honours, and students in most conjoints will take one extra course per year and then also study for an additional year. One of the highlights of the engineering degree is the ability to be able to go on exchange for a semester. So you can choose between 125 partner universities in 25 different countries. Students can study for one semester in either the semester 2 of their part 2 or second year, or either semester in their part 3 or third year. So the courses that students take at their exchange universities can be credited back to their study in the Bachelor of Engineering degree. So students can experience different cultures and see different places and enhance their student life and CV. So in 2019, engineering students went on exchange to countries all around the world. The exchange program has been put on hold this year due to the COVID-19 situation and border restrictions, but it's hoped that the exchange program will be up and running again in 2021. And now I'll hand it back to Kelly.
Another really integral part of the engineering program at the University of Auckland is making sure that the engineers get experience working on real-world projects. And we do this in a number of ways. We have practical work requirements for the students, but also we have final year projects. We call these their Part 4 projects, many of which are sponsored by industry. And students work on real-world projects together with a supervisor. Another kind of the culmination of this real-world experience is Systems Week. And this is in the last semester of your engineering degree, where lectures are canceled for an entire week so that all of the engineers studying can come together to work on large interdisciplinary projects. They come together in groups of about 25 students, and they work on real-world projects together, trying to handle the views of many different stakeholders, the risk, many different dimensions of real engineering problems. And now I'd like to introduce a few of our graduate speakers who are going to share their experiences of what it's like after getting their engineering degree at the University of Auckland. So first I'll hand it over to Orti.
Hi there. So my name is Orti and I'm actually a very recent graduate. I finished my degree in computer systems engineering at the end of last year, and I now work as a software developer at TradeMe. So the first thing I get asked is, what is computer systems? And basically it's kind of the middle ground, integrating like hardware and software. So not just writing code, but also designing machines that run that code. And I chose to do this because I just found it quite fascinating. It was something I had never heard of before until I started studying in my first year. And I knew that there were lots of cool projects that would be lying ahead in the next 3 years that I'd be studying. For example, I did end up making a robot that could play Pac-Man, and that was pretty cool. And then when it came to finding an internship for those 800 hours that Kelly mentioned earlier, I looked at both hardware companies and software companies, and I found this job at TradeMe and I applied for it, and I just really liked the people that I met while I was being interviewed there. I really liked the type of work I'd be doing, and so that's how I kind of ended up in a more software type job. My internship was super hands-on. I got put straight into a product team where I was building stuff that, alongside other developers, some who'd been working in the industry for like 15 years, who were really great and helpful. And then some of the stuff I worked on is actually still live on the TradeMe website today. And luckily, I enjoyed my experience there. They liked having me there. And so at the end of my internship, I was like, sorry guys, got to go back to uni. And they were like, hey, once you finish uni, do you want to come back? And so I started back earlier this year. And I've continued working on similar things to my internship, where building new features for the site. And now that I'm there full time, I get to also be involved in the discussions for the wider products that we are developing and how engineering can kind of fold into those and the best way to implement a really nice, modern, cool site. So that's me. So next time you use TradeMe, if something is really cool, then I built it. And if it's broken, then I didn't build it. And I will now pass back to Kelly.
Dan will hand it over to another graduate, Israel.
Hey, thanks, Kelly. So I'm Israel, and I study chemical materials engineering. I graduate a wee bit earlier than that in 2012. So originally I actually chose that specialization. I found material science part of that quite interesting. And then parts 2, 3, and 4, you find out actually it's more of a processing paper. But even that was quite interesting in that, you know, you get into detail, the materials in small scale, and you also look at the sort of big picture thinking. And I thought that was quite good in terms of when I picked out a uni and sort of looked lots of different sort of careers and lots of different fields you could go to from there. And so I was lucky enough to get basically start in the graduate program at New Zealand Steel. And through that, I had lots of opportunities to work in lots of different plants. So for those who don't know, there's a huge manufacturing site in Glenbrook, New Zealand Steel Mill. And I got an opportunity to work in the steel making, iron making, even they have a mine site down there near Waikato North Head. So through this company and the graduate program, I got rotated in different roles. And it wasn't just technical specialties I was picking up at the time, but there's a lot, you know, getting a job in this sort of manufacturing environment, there are a lot of different opportunities, lots of different roles that you can pursue. And as an outcome from that, I'm now the QA manager for Pacific Steel, and we manufacture reinforcing steel, bar, coil, mesh feed, and wire products. So probably if you go around, see a bit of infrastructure going around, hopefully you'll see our product, you'll see seismic written on the bar. So it's really good to have taken on this degree and being able to contribute, not just, you know, use my skills and work in something in my interest, but also contribute to what New Zealand's doing and helping really build New Zealand manufacturing. There's been some big projects I've had a chance to be part of. Early on, you know, the manufacturing steel was quite a mature technology, and coming on as a graduate, you have, you know, a few different ideas, you take on projects, and there's been some involved with the steel making process. Did some technical modeling, changed the mix, and there was you know, I think $1 to $2 million of savings there. And that was where you could come in with some fresh ideas and challenge something that's been done the same way for a long time. And I think for our industry, because it is a mature technology, if you look globally, there's lots of different manufacturers, not just in steel, but all over the show of different levels of technology. And coming in with a graduate and new ideas, I think there's a lot of gains to be had, especially in optimization, AI, and big data. So for those that are willing to capitalize on that, I think there's a lot of work that we can take advantage of and improve those processes and systems. Thanks, hand it back.
Thanks, Israel. And one more graduate tonight, Ang.
And I'm the software engineer who was slow on the software transition. Hey guys, my name's Ang. I graduated 2 or 3 years ago. And fun fact, I didn't actually want to do engineering when I first went to university. I spent 1 year doing biomedical science because I wanted to be a sports doctor for Arsenal, which aren't doing so well. And then found out it was actually really boring. All that we were doing was rote learning things and weren't actually doing any problem solving. My sister was doing engineering and she's like, hey, why don't you give this a go? So I did it. In my second year, I switched to first year engineering. So I was set back a year, but really it was way more what I wanted university to be. There was a lot more problem solving, and immediately whatever I was learning, I was able to apply it straight away. Meanwhile, I was also part of there's an entrepreneurship program at the University of Auckland. And through that, I was able to see, okay, when you go on to choose one of your 9 specializations, I was like, okay, software is the most fun. And it also scales the best in terms of the quickest way to have an impact on a lot of people. So now I have a startup company called StrutFit, and we make it really easy for you to buy footwear online. So currently when you go to buy shoes online, you often don't know what size you are in that specific brand because styles fit differently. And then if it's a completely new brand, you'll have no idea. So we let you scan your feet with your phone, and we get the length of your feet down to a millimeter of accuracy. And then we work with that brand to give you exactly the right size. That's been really cool, and it's good to know that you can build a really global company. Like you look at an Instagram and you're like, wow, they're $1 billion company. Just know that you can build that from New Zealand, and that you can do that with a software engineering degree. Cool. Back to Kelly and Colin.
Yeah, thanks very much, Ang. So now we're going to take a moment to talk about this question: how do engineers rewrite the rules of tomorrow? And before Kelly and I give any thoughts on that, we'd like to hand it back to our graduates, starting with Orti, to talk about how they would answer this question based on their experience.
Yeah, so one of the ways that I wanted to answer this question was actually a project that I worked on in my internship that I didn't really think would be that big a deal until COVID-19 hit. And so one of the things was I work for Trade Me Property, and quite often when people are buying houses, they want to go and look at the house, and they want to go take a tour and go through an open home. And so we implemented these things called 3D tours, where there's like a tech company that goes in, they like scan all the things and then build the model of the 3D tour, and then we integrated that onto our website so that agents could then upload this tour. People that are interested in that property could then click on that and view that property. And you can imagine during COVID-19, where people were quite interested in buying houses but obviously couldn't actually go physically see them, that was something that suddenly became a lot more popular. And it was really cool that something that we had thought of a year ago had this whole new like meaning and importance, and it's something that now that people are more comfortable with it have been using a bit more. So yeah, that's my answer.
Thanks very much, Orti. I'd now like to address the same question to Israel. How do engineers rewrite the rules of tomorrow?
Sure. In some ways, it's been interesting working in an industry that is quite mature, and when you come in, there's a lot of people been there 10, 20, 30 years. I think there's a lot to be said for those industries which are key to carry on. There's a lot of new tech going on, but there's a lot of things to be said for industries that just need to still be there. Steel manufacturing, you still need to build roads, buildings, concrete structures, and there's a lot of old ways of doing things and old habits that engineers can bring on new ideas and new ways of thinking. And part of that is knowing what's out there and how to apply it. And the other part is actually convincing a group of people to do it. And there's a lot of soft skills. There's a lot of moving teams. And that's part of, you know, I've seen in our business that you can go into sort of a technical route and you can sort of get pushed into a manager's sort of route. And that's not something you necessarily might think of at uni. But at the end of the day, if you want to make big changes, if you want to see the future change, it's not up to individuals, it's up to teams. And as engineers, you know, we have the understanding, we can have some new ideas. And if we're willing to put ourselves out there to lead teams and bring people together, then that's the way that we can bring our ideas to fruition and really lead the people and these existing techs to improve themselves and make, you know, the world better overall.
Great, thanks very much, Israel. And now, Ang, same question. How do engineers rewrite the rules of tomorrow?
Cool, so what we're doing at StrutFit is bringing footwear retail, actually just retail in general, into the future. So we literally are rewriting the rules of tomorrow as far as retail is concerned. What we've noticed is large companies are very bad at innovating in general, and then specifically in retail, that's just not going to happen internally. So what we've been able to do with a really small team in Auckland is work with really massive companies like Next. They have like 700 stores that do $4 billion in profit, and it's just insane. But to be able to do that with a team of 5 and now soon 7 engineers and actually create change which will impact millions of people, that's awesome. And we're able to do that through software which scales really well. One of the things Colin mentioned earlier was through engineering, you get to see how things work at a really large scale in terms of systems, but also being able to break them down and see how they work. And it's just those basic principles which we've applied to the vertical of retail. And through that, you can actually see, hey, you know, what are they currently doing, and what can it look like with, if technology wasn't limiting you, what could that look like? And that's what we've been able to do. And then being able to actually see, hey, how can this fit with their massive architecture, with all their millions of users? How can you actually bring that to the real world? So the micro and the macro scale that we got from engineering was really useful. And actually, even the most recent person we've hired, who's a salesperson, is actually also an engineer. So certainly we value engineering, and it helps us definitely shape the future. Cheers, guys.
Fantastic. Thanks very much, Ang. I'd now like to invite Kelly to answer the same question.
Well, we've talked a lot about problem solving and how engineers are problem solvers. And really, engineers are solving the problems of the future as well. In my department, we have researchers looking at how we can power cars wirelessly as they drive on the highway, how we can use robots to pick fruit and pollinate plants. We have such exciting projects going on at the University of Auckland. But we're not just solving problems that are our own problems. We have to understand the needs of others and solve other people's problems as well. So my research group is looking at ways to automatically mine text that's being put online, so feedback that goes up online about software products, and how we can automatically help software teams know how their software should change so that it can be the most usable software products for a wide range of people.
Thanks, Kelly. And in my own department, civil and environmental engineering, there's a lot that's really exciting in the future as well. When you think of smart cities, the way that technology and the environment are just going to be integrated more and more in the future, there's a lot of really great opportunities there for the engineers of the future to really rewrite the rules of what's possible. If I think of other disciplines as well, we can think of biomedical engineering and really pushing the limits of what's humanly possible through technology. So these are just a few of the answers to the question, how do engineers rewrite the rules of tomorrow? Now, to talk about some next steps, just to quickly recap what we've covered. So we've talked briefly about who engineers are, what they do. We've talked about how you'll get there through our degree. Jane's given a really good description of how to get into the degree and some of the opportunities available for scholarships and exchanges. And we've heard from our graduates about what engineering has meant for them and how engineers rewrite the rules of tomorrow.
And just some next steps. So there are more sessions of this. You can join Colin and I in the future sessions that are coming up this week and next week. We also have a lot of videos online that explain about our program, the university, all sorts of things. So you can find those online. And remember, we'll be sending the recording for this video out to all attendees. You can apply. The applications are now open for next year's students. And we also have some more upcoming events. So sometime in August, we're going to be having Open Day, and details of that will be coming out shortly. And we also have Ingenuity Day. So this is a day where we bring high school female students to the campus to learn more about what engineering would be like for them at the University of Auckland. And now it's time to answer the questions that you've been putting up on the question and answer forum. So our top question at the moment, I can see that lots of them have already been answered by our student academic advisors behind the scenes, so thank you for that. Our first question is, how do fast track offers work for BE-ONs, and are they offered for engineering conjoint degrees? And somebody from the Student Academic Advisor group is going to answer this live.
Thank you, Kelly. So fast track offers are given to high performing students. Now, every conjoint degree with engineering is available for fast track. So please submit your application and it will be considered. Back to you, Kelly.
Thanks, Jane.
Thanks, Jane. The next question is also one that's probably best answered by our student academic advisors, and that's, can you still get into the Bachelor of Engineering with Honours course if you don't pass one of the physics or calculus externals?
Thank you, Colin. We have had students admitted into the Bachelor of Engineering who haven't passed all of their external credits. your application will be assessed in a more holistic way. The results from your other subjects will be looked at, and your rank score will be weighted more heavily. So we suggest that you submit an application, and if there are spaces available, it will be considered.
Thanks, Jane. And it seems like most of the questions are for you, so I'll read another one. And when do we get told if we are unconditionally approved in the course? Is it as soon as we meet the specific requirements, or is it at a set time after examination results are out?
So it depends whether you're doing NCEA, IB, or CIE. So once the results are out for NCEA, there is a process that runs in the Faculty of Engineering, and everybody's application will be assessed. Similarly, once the IB results are out, students who've done IB in year 13, all of their applications will be assessed. So it won't be long after your results are out that you'll know whether you've been given an offer for engineering.
Thanks, Jane, and sorry to keep you and the team busy here, but we have a number of other questions for you and your team. The next one is, how many Top Achievers and Pacifica Top Achievers scholarships are there on offer?
That is a very good question. I'm not sure what the answer is off the top of my head, so I'm going to hand that over to Angelo Ramos, who is another one of our student academic advisors who's working away in the background. Angelo, if you could find that information out and pop it in the chat, that would be great. Thank you.
Hopefully appear shortly. The next question, also for you, Jane. What are the benefits of a fast track offer? And once we receive it, what do we need to do?
So once you receive a fast track offer, all you need to do is accept your offer if you want to take up the offer of place. So the benefits of the fast track offer are you're given a conditional offer into the program that you want. So basically, you're halfway there.
Okay, thank you, Jane. Just moving our way down the questions. The next one is also for you and your team, and that's, what is the minimum NCEA entry score that you will accept for BE ONS, or does everyone have to get 260?
That's a very good question. Thank you, Harriet. So not everyone who does NCEA needs to, or not everyone that we've accepted from NCEA has achieved a score of 260. Now, it will change from year to year what score will be accepted, and it really depends on how many students do get that 260 and are given a guaranteed offer. So yes, it's possible to be admitted into engineering without getting 260, but we don't know what that number will be for next year. But we suggest that you submit your application anyway, and it will be assessed.
Thanks, Jane. And to give Jane a slight break, we're going to go to a question for Ang. Somebody would like to know, what is the university's entrepreneur program?
Cool. So the entrepreneurship program is called Velocity, and it sits agnostic of regardless of whatever faculty or degree you do. So if you do arts, or if you do engineering, or if you do science, you can still be involved. It's actually a really great place to get together and meet lots of different people from these different degrees. But I found that it was really good, and in fact, quite a lot of engineers do it. It's a good way to round out your engineering ability with that business ability. I get a lot of people asking me whether it's worth doing that conjoint and BCom and doing engineering. My personal opinion is you can probably get what you need from Velocity if you're looking at starting up a company. But if you want to learn more about the specific, say, administration sides of business, then do the BCom degree. But yeah, you can find out more, I think, if you just Google Velocity and University of Auckland, and would highly recommend it for everyone to get involved.
Ang.
So the next question is again for Jane and the Student Academic Advisor team. When do the scholarship applications open?
Hi, thank you for your question. So it really depends on what scholarship that you apply for, because a lot of them have different opening and closing dates. the best thing to do will be to go onto the University Scholarship website and have a look at the scholarship that you're interested in.
Thanks, Jane. One more about scholarships while we're on that. Are there any scholarships for refugee students?
That's a very good question as well. I'm not sure off the top of my head, but Angelo, if you could please have a look and see if there are scholarships for refugee students. I'm pretty sure there are. And if you could put some information about that in the chat, that would be great.
Great, thanks Jane and Angelo.
So the next question is one for Kelly and I, and that's how many choices can you have with the disciplines of engineering from your second year, and what happens if none of those choices work out?
So we asked students to rank their top 5 choices, and correct me if I'm wrong, Colin, but I'm pretty sure everyone gets at least their top 5, one of their top 5. Almost everyone gets their top first or second choice.
Thanks, Kelly.
The next question is also for Jane. Are fast track offers based on the level 2 results or year 12 results for some students who are advancing in some subjects?
Hi, Jenny. Thank you for that. That's a good question. I am not sure off the top of my head. Sorry about that for this answer. So, Angelo, if I could get you to quickly have a look and reply in the chat, I'd appreciate it. Thank you.
So the next question, I believe, is also for Jane and the team, and that is, how many guaranteed places are there?
That's a very good question. So how many guaranteed places there are will depend on how many students achieve the guaranteed entry requirements. So we have to give every student who meets the requirements a space, no matter how many students meet the requirements.
Thank you. So I'm going to try to answer one of these. So are there specific engineering majors that need a specific score marks in order to take them? And so your high school scores and marks no longer come into play when choosing your specializations. We consider your year 1 grade point average. Jane, correct me if I'm wrong in that. Yep, she's giving me the thumbs up. That is correct. So it's all about your first year of study at the University of Auckland into getting into your specialization.
Thanks, Kelly. The next question that I have here is, are you able to take more than one specialization in the second year of your BE Hons? Now, I don't believe that this applies to the conjoints, but that you're talking about within engineering. My understanding is that that's not possible. Jane, please correct me if I'm wrong on that. Again, I'm getting the thumbs up, so I believe that that's correct.
Thank you. I've applied online for engineering. I've had no confirmation via email or mail. Do you send out any confirmation of an application, or is it just available online in the student portal? I'll let Jane answer this one.
Thank you very much, David. That's a good question. So if you've applied, if you've managed to submit an application successfully, you should have received a confirmation email in the next working day. You can also check online in your student portal. You'll be able to see what the status is of your application. What I can do is we'll give you in the chat the email address for the Engineering Student Centre. And if you send us an email, myself or another one of my colleagues in the Student Centre will be able to have a look for you tomorrow.
Thanks, Jane.
So I've got a great question here for some of our graduates, and so I'm going to pass it to them in a moment. Would you say that first year engineering is a great step up from high school? So it's probably best if we hear from our graduates for that. So I'll pass over to Orty.
Technical difficulties. I wouldn't say it is a step up, definitely, in the sense that you go from a classroom environment where you have that one-on-one time with your teacher, or like, you know, your teacher, you feel a lot more comfortable with going up to them. Whereas in a big lecture theatre, it can be a bit more intimidating, but the work itself isn't actually that big a step up, in my opinion. Obviously there is that learning curve that comes with that, and with, you know, progressing to the next step, and then also to, you know, that what I said earlier about not having quite as much support readily available. However, the university does have a lot of things in place to kind of help that transition. Things like the Part 1 Assistance Centre, which if you go to like an open day, or I'm sure they'll talk about it at another one of these things, where they have older students on hand to actually help you with like the papers you're working on.
Thanks, Orty. And Ang, do you have anything you'd like to add to that response?
Sure. So, so long ago, it's pretty similar. It depends what you did. I did Cambridge, and with Cambridge, it wasn't that massive a step up, and I did have that year of biomedical science. I think what's worth saying is hard work is something I learned much later, and it's something I wish learned easier. So even if it is a big step up, what's really valuable is learning how to work hard. Because grades, after you get out of uni, grades don't matter. Like there's people who get C's and go on to make actually one of New Zealand's most successful companies. But it's really just learn to work hard and commit yourself to that work. So it's a roundabout and not really answering the question, but that's probably what's more important.
Thanks, Ang. And Israel, did you have anything that you'd like to add as well?
Sure. I mean, I was even further back in 2012, but I remember I had a gap year because originally I wanted to try and get in the Air Force, which didn't quite work out. But coming back into it after a year, I did find a few things challenging, particularly the maths for a bit, but there is support here. I think one of the biggest changes is that no one's looking over your back or trying to say, hey, make sure you get this done. It's all kind of what you apply, and there's heaps of support services, which is great. You know, people around you are willing to help. You're all kind of in this together. So the environment's really good. The only thing I'd really say is take all the opportunities there are, you know, take the scholarships, ask for the help, you know, ask questions in tutorials. Like it's really up to you what you make of it. So the more opportunities you take, the better off it's going to be. And the extracurricular stuff, you know, the first year I found in some ways to be a bit full on, but put your hand up for everything, you know, try everything, not just in your course, you know, meet a few other people. There's a lot of support out there. So I found it a lot better than high school.
Thanks, Israel. The next question I'm going to ask for Colin. What makes the University of Auckland engineering different to the engineering programs at the University of Canterbury?
So that's a great question, and it's one that we get quite a lot. One of the things that I'll say, and I have some experience with the Canterbury program, is they're both very reputable programs. They're both very strong. The University of Canterbury has a suburban campus. The University of Auckland is in the central city. And we believe that gives us some advantages in terms of really being connected to employers, to business, to local government. Your finger is very much on the pulse of what's happening in the city. Our program also really prioritizes that entrepreneurial aspect that Ang has already talked about. And so those are some of the points of difference that we really try to play.
And can you speak to the difference at Vic?
I don't have any experience with Vic, so I can't speak to that personally, no.
Okay, I also do not have experience with the other engineering programs in New Zealand, but I know that the University of Auckland is very highly ranked and internationally recognized as a very good engineering program. Another question for you, Jane. What's the percentage of accepted students getting less than the guaranteed score in 2020?
Hi, thank you for your question. I can say that there were quite a few students who were admitted into the Bachelor of Engineering who did not attain the rank score, but unfortunately we don't have those numbers on us tonight.
Thanks, Jane.
The next question is there an aerospace engineering program at the University of Auckland? And my understanding is no, there is not. Aerospace is maybe taught within some of the other disciplines, but it's not a separate discipline by itself at the University of Auckland. So the next question I'm going to pass to Orty, which is, would a computer systems engineering major disadvantage you from a software development job in comparison to a software engineering degree?
That's a really good question. Short answer is no. I actually found that because I'd studied computer systems, I had worked on a lot of different projects from my software engineering friends had. And so when I went into job interviews and they'd see I'd gone to Auckland U, they'd be like, yes, you're going to talk about this project. I'm like, actually, no. I'm going to talk about a completely different project. And then on the other hand as well, I think about problems a little bit differently to my software engineering friends, and that kind of diversity of thinking is super important in engineering teams because it means we approach problems slightly differently. And so yeah, 100%, I don't think it's a disadvantage. And I got a job at a really popular software engineering company without having any issues because I studied CompSys.
For engineering, and Orty was in one of my classes. In your final year, you can take software engineering electives. So a lot of computer systems engineering students do that. So in that final year, there's a lot of flexibility to be able to broaden your expertise. And another question for all of the graduates. So what was the best thing about studying engineering at the University of Auckland? And maybe we'll start with Ang.
The best thing would be, when I say the people, it is the best ranked university in New Zealand. Because of that, you get a certain caliber of people coming through. So it's like from a professional standpoint, like all the people I've worked with, who are part of the startup are people that we went to uni with, which is weird. It's like weird hiring your friends, but just know that that's the caliber of people that we want to work with. And also just like friends, we just met so many really good friends at the University of Auckland. So because of both those reasons, I would say the people. Cool.
Yeah, I actually have to completely agree with Ang. That's probably, probably 8 years out now, and that's the most memorable thing from uni. The people, the friends I'd made, and I think what do you say about the caliber of people? Because I look back on my friend groups now and people on the same class as me, and they've gone on to do some quite amazing things. And it's funny to think the friends you made back then, running plants and managers here and in charge of this there, and it's quite impressive what people can do coming away from a degree, 8 years down the track. So it's definitely the people I got to meet and still keep in touch with.
Thanks. And Orty?
Yeah, so in addition to the people, because I think that's going to be the answer here for most people, it's also the extracurriculars and clubs we have at Auckland Uni. There, especially within engineering, we have an incredible culture, and my fondest memories of uni, as much as I loved your classes, Kelly, were definitely all the club events that I'd go to. And I was someone that I was quite shy in high school, and then when I got to uni, I was like, I'm just going to join these clubs, meet different people. We have a club that called the Engineering Review, which puts on an annual theatre show. And then I ended up doing that for most of my time at uni and was obsessed with it. We have the Women in Engineering Network, and they do a lot of cool events for both men and women. We have the Engineering Society, and they put on lots of professional development events, but also really fun social events. And so it's a great way to, I think at Auckland Uni, when you study engineering, there are just all these places to meet people, get new experiences, and really branch out.
Okay, so what I took away from that is my classes are awesome. Thank you. We have another question that's very related to what Orty just shared.
Yeah, so someone had actually asked what are some of the other extracurricular activities that are available to students at the University of Auckland. So Orty's already given us a fantastic answer to that. So I'm now going to pass to Israel to answer the same question.
Sure. I was just thinking as you go into that list, I wanted to plug in the review. By all means, the show. Just get into it. There are so many clubs. There's everything under there, but the most memorable thing for me is absolutely the review. And it's a good chance to take a dig at the other some other faculties on site, but really, again, the same thing. Coming out of high school, you don't think you can do it, a little bit shy, and everyone there is really supportive. So if you even think maybe, definitely do it. Just jump all in, backstage, up front, whatever it is. But it's definitely a chance to, I guess, break new ground and meet a lot of people.
Great. Thanks, Israel. And Ang, same question about extracurricular activities.
Yeah, so I've already mentioned the entrepreneurship program. I was also part of the review, and the review is a stage production which you put on for like 1,000 people. It's a lot of fun. Basically, anything you want to do is kind of available. There's an investment club. There wasn't a food club, so one of my friends started up the food club. I don't know if it's still going, but like that was a thing. So if the club doesn't exist, know that you can start one. There wasn't a dance club a couple of years ago, and then they started one up. So there's basically anything you can imagine, and if you can imagine it doesn't exist, just start it. Thanks.
Great advice. I know Jane is getting bored, so when looking at scholarship applications, do you use NCAEA level 2 or 3 rank scores?
Thank you, Kelly. That's a good question. Now, that is going to depend on what scholarship that you apply for, because scholarships all have different regulations and requirements. So what I suggest is go onto the scholarships page on the university website and have a look at the regulations and see what is required for that particular scholarship you want to apply for. Thanks.
Thanks, Jane.
And another one for Jane and the team who are working very hard here. If I've already filled out the 2021 application online, do you automatically receive my NCEA results?
Correct, we do. Once the NCEA results have been released by the Ministry of Education, the university gets sent a big file with everybody's results. So you don't need to do anything after submitting your application, because your results will come to us.
Okay, one that we'll ask the graduates to see if they have any experience in this. The question says, does taking a conjoint affect your chances of success in each course significantly, or is it typically worthwhile? Orty, would you like to go first?
So I did do a conjoint, but I do have a lot of friends that did their conjoint, and a lot of them, because we finished our engineering degree like last year, are now doing their conjoint year, which is the final year. And for all of them, I found that it did not affect their chances at success at all. They obviously it does require a little bit of extra work, but if you are truly passionate about the second degree that you are studying, then it pays off and it works well. Yeah, someone here might have done a conjoint, so it might be more helpful.
Thank you. Anyone do conjoint? No, none of our graduates here did do conjoint. Thank you for sharing your experiences through your friends with us, Orty. Colin?
So we've got about 5 minutes to answer a few questions before we wrap up. The next one that I have here is again for Jane and the team, and it's, if I receive a conditional offer into the BE ONS and later do not meet the requirements, how do I accept my second choice? Would I need to decline all other offers as soon as I accept the conditional offer?
Thank you, that's a good question. To my understanding, students can accept as many offers as they like, and students can actually be admitted into 2 different degrees. So you can just accept all your offers if you want to, and then once you've decided what program you want to do, then you can decline the offers for the programs that you don't want to go ahead with.
Great, thanks, Jane. I'm going to ask Colin a question. And how can engineering be used to help the environment?
It's a fantastic question. Often, historically, engineering was something that was done to the environment and normally not with very good outcomes. But more recently, there's been a real resurgence of making room for nature, building with nature. I teach courses on coastal engineering, and one of the emerging paradigms there is called nature-based coastal protection, where you're really trying to work with natural ecosystems, taking advantage of the protection that they provide, rather than sort of implementing something yourself. In the future, I really see this just becoming seamlessly integrated, where we're going to be developing technological innovations and solutions that are able to enhance the natural environment's ability to treat water, to provide flood protection, because that's the areas that I work in. And so it's a really exciting time.
Thanks, Colin. The next question is, why did the biomedical engineering course have a lower number of places compared to the others? Is it especially hard or not many people choose it? Colin, do you know the answer to this one?
I'm not sure, but I'm going to hand over to Jane because she may have a better answer than I do. Thanks,
Great.
Jane.
Thank you, Colin. So the two main constraints on the caps for the specialisations are the resources that are available in the faculty for a particular specialisation, and also the demand for graduates. So we don't want to flood the market with graduates for a specialisation in which there aren't enough jobs. So those are the two main reasons why biomedical engineering the cap is so low. However, you could see for civil and environmental engineering, the cap is very high because there is a high demand for graduates from those specialisations.
Thank you, Jane.
And on a related note, and Jane, you might be the best one to answer this as well, although our graduates might be able to offer some anecdotal evidence. Do you know what percentage of engineering graduates got career jobs from the 2019 class? In other words, jobs within the engineering industry?
Thanks, Colin. That is a very good question. I don't have those numbers on me at the moment, but I do know that pre-COVID, the job outlook for engineering graduates in all specialisations in New Zealand was good. Do any of the other graduates would like to respond?
Cool. I'm the only one from my class who doesn't have a job in engineering, so that's cool. But also, engineering doesn't just let you do engineering jobs. Like, know that once you have this grounding in engineering, you can actually go off and do most jobs. Like, you're not going to become a doctor because you need a degree for that. But anything which doesn't require degree expertise, engineering actually sets you really up for really well. So I'd say don't be so fixed on your current job that you wouldn't take a better one. Would be my advice there as well. Thanks.
Unfortunately, we don't have time to get through all of the questions tonight, but thank you very much for being engaged and asking so many questions. We'll finish it up with the next top-ranked question, which is actually not a question, but a thank you to everyone for their time tonight and for answering all of our questions. We appreciate it a lot, and thank you. So I would like to reiterate that to everyone that's here, but also to everyone that worked tirelessly behind the scenes to set up this event, and to all of you. So thank you for joining in and listening to us tonight, and we hope to see you soon here on campus at the University of Auckland.
Thank you all very much, and good evening.